Hello, everyone. You guys hear me? Yeah? I don't know. I can't really hear myself from this side. So, we're gonna get started. So, if you guys can settle down, and we're just gonna get the streaming started. Yeah, good. All right, everyone. We're gonna get started. So, thank you very much for coming. Yeah, welcome to our TorontoJS meetup. Thank you guys for coming because, some of you come from very far away just to, have a chat. Some of you maybe just come close by from your office and have a pizza, but that's also great too. We're all here to, get together and listen, despite our long commutes and busy schedules, especially on a weekday. About us, TorontoJS, we've been around here for a while. We have a website, TorontoJS.com. You can visit, participate in our community. Of course, most of us know we have a Slack channel. Maybe that's where most of you come from. But if not, later on we'll have a QR code so you guys can join and visit us, get involved, and do all the stuff that we do here, meetups, group projects, and things like that. Let's talk a little bit, take a few minutes of your time if you don't mind, about who we are. Explains this very well. We're a volunteer, nonprofit group, corporation. And we aim to help, support all developers or, aspiring developers in their journey to just learn more about JavaScript, but not just JavaScript, maybe TypeScript now, but any language now really. But we want to share your passion for JavaScript and all the software design and development that comes with it. And we love JavaScript. Just a quick word about a code of conduct. We just want to make sure we have a very safe community. And if you feel like there's any point where in our community you're not comfortable with something, you can always let us know. Reach out in Slack or any other by email. We're looking to provide that abuse-free, harassment-free, just a good experience for everyone, to be honest. And if you're really not sure about, what constitutes the code of conduct, you can always look it up. There's a link here, and or talk to us about it to see if there's anything we can do. Now, a big part is our sponsors. We are very privileged to have really good sponsors to help us and bring this great, free, accessible event to everyone in Toronto. Yeah, that's right. Obviously, super.com is the office building you're in right now. So we want to give a big thank you to that. But we also have sponsors like DragonflyDB and Sanity.io. And huge thanks to them for making this all possible and for us to be able to host this event. And also you guys. Without you guys showing up to the event, we won't have events. So thank you guys for bringing this all together and making an unforgettable experience. And we keep growing our community. But just to let you know what these guys are, super.com is an all-in-one travel app, putting more money in your pocket through savings on hotels, cashbacks, and cash advances, and so much more. Check out super.com. You guys know what the URL is. Dragonfly. Dragonfly is actually a very close link with Redis. So it's a drop-in Redis replacement built from scratch, used for modern cloud workloads. 25 times higher throughput, 12 times lower latency, and up to 80% lower cost. That's a lot. Fully compatible with Redis APIs and tools, so no code changes needed. Try it out, dragonflydb.io. And finally, shout out to Sanity. Sandy is the content operating system. So it's a fully customizable all-code backend for all content-driven websites and apps, their builders and creators, and check them out on sandy.io. And let's see here. So more about us. We're gonna flaunt some stats here. We host these virtual events. We host some online events. I used to do a system design tutorial, but altogether, we have around 13,200 plus members on Meetup, 6,700, probably higher by now, members on Slack, 1,700 members on Guild, and 50 dedicated volunteers. So we're gonna do a quick shout out here. Manvinder is here. All right, he'll see this later. Yeah, thank you. Okay, Bijishari, Brandon, I'm there, but that's fine. Florence is still manning the check-in. hey, good job. And I think I'm missing someone, but actually, no, that might be it. So thank you guys for putting your time in and helping us organize this thing. We always have trouble with lights or something like that. So this is what we're going to do today, 6 p.m. Okay, we already done it, so never mind. We're already at a little bit 6:25, and I just welcomed you. So what's going to come up is we're going to have a talk by Fabio, and then he'll talk for maybe 30 minutes, but it could be longer. We're flexible on that. And at around 7, we'll have a talk by Jatinder. After that, the office is open for you guys to talk to anyone, make some connections, talk with the speakers or volunteers to see how you can get into help us out with future events and meet more people. Oh yeah, and we've also started streaming. So everyone say hi to the world. Hello, Ottawa, Winnipeg, maybe Calgary. You know who you guys are. But so if you find that you cannot show up to a meetup, just come to watch the streaming, or you can always watch there. And make sure you hit the subscribe button, like not here, but like when you get onto YouTube. And there's our URL here. Yeah, get your cameras ready. I'll give you 30 seconds. You got it? Okay, we're gonna start the timer now. So interested in volunteering? You want to keep the conversation going? And you want to know about next events? Yes, see? Yeah, get on that QR code. Join us on Slack if you just want to, I'm actually in the cooking channel. I haven't cooked enough to make a picture, but we got all sorts of things to do there. So join us and get involved in the community. Okay, so we're going to go to our first speaker now, and give us a second for him to get set up, and I hope you enjoy the show. Okay. I'm just going to plug it. Okay.
Is the whole thing to share the screen?
Yeah, I think you have to share screen, and I'll give you the mic. A second here. Oh, here we go. Of course. It's the easiest way to get out. There you go.
Oh, it's a magnet.
Yeah. Magnets.
Okay.
Let me put this on first. Harder than it looks when you're not prepared for it. Can everybody hear me? Awesome. Oh, what? I already did this. Where is my screen? Ah, there we go. Is it working? Okay. So, hello everyone. Oh, okay. Good. All right. So, hey, We are ready to go now. Hello, everyone. I'm going to talk about HTML 3000, which is, in my humble opinion, a better way to write HTML and markup in general for apps without being constrained by the document structure, essentially, the document model that we have. So, who am I? I am Fabio Neves. I've been doing this for a long time, since last century. So 25 is actually not to scare people. It's actually a little bit more than that. When I started, I was doing banner ads and that sort of thing that nobody cares about anymore. I am a senior engineer at Webbook on the front-end platform team. It is a Rails app. Look at that. But I not only work with Ruby and Rails. I'm actually a polyglot developer. I actually used to teach at a boot camp, and there's a bunch of people that used to be my students here, which is always so cool to see, and where people are right now. But yeah, also work with Node.js, with React, with all of the things that you can imagine. I've been there. And yeah, I've been using HTML since CSS was not a thing, since before that time. Therefore, I have opinions. Right? Because usually, you know how it goes. Old people have opinions. And I do have a website right there. It's myname.ca. It's not hard to remember. But let's get to it. Okay, so what are we talking about here? Okay, so HTML was created at CERN by, in the beginning, the objective was to share just like scientific papers, right? If anybody here has read a scientific paper, you know that scientific paper has lots of footnotes and references to other papers and whatever. So Tim Berners-Lee, his idea was just to make it easier to follow the references and read other papers, okay? And because we are talking about scientific papers, the markup language was created with tables, with paragraphs, with headings and stuff like that. It was very basic. It was text only, right? And there was not even a document model because it was literally just markup. There was no JavaScript. That came like way later, right? But the semantics of HTML, they were built on top of the idea of documents, okay? And that survived and served us well for a long, long time. During the 2000s, we had the blogosphere. It was like the best time of the internet. Don't fight me on this. But it was articles, essentially. People sharing articles and news websites, like that was the main thing that people did. It was sharing text, sharing articles. So if you look at the HTML that we have, you can still see that because you have article, side header, footer, and the other things that we had since the beginning, okay? So it was meant for that. But things evolve, right? And now we have this sort of thing. Whenever we start a project, it's usually not just content. It's usually not just text. Much on the contrary, it's probably not that. Okay, so we need to build these interfaces that we see here. We have panels, we have dials, we have graphs. We have, with the exception of forms, which are still very much semantic, most of the things that we're seeing here, they don't fit very properly into a document paradigm, right? Because where is an article here? Where is an aside? Where is a paragraph, right? There's nothing like that. So what do? We shoehorn everything into basically two elements. We use divs and we use spans. There's still main and things like that, but bear with me here, okay? You know that you use a lot of divs, right? But what the hell is a div? I can tell you what a paragraph is. I can tell you what an article is. I can tell you what nav is. Nav is still used, there's always a navigation and stuff like that. But div, nobody knows what is a div. Okay, div is basically a bucket where you throw classes at to tell you how it looks like and how it should behave, okay? The problem with that is you get to a situation where we have code that's very hard to parse without looking at the output of that code. So I have an example here, okay? And this is a prime example of the problem that we have. We have essentially just divs and spans. And if you look here, if you have used Tailwind before, you can kind of sort of understand what this will look like, but it's very hard to say what this is, right? This whole thing here, you can see that there's an image there somewhere, But like, if we exclude the image, I don't know what this is, right? What is class warfare? What is the anti-patterns? What the hell is this? Okay. If you find this code familiar, it's because it's actually the example code on the Tailwind website. It's the first thing that you see. So by looking at this, we can tell that this is basically like a now playing kind of widget. It's kind of like, maybe an album is playing, and there's an animation, showing how you can change things here, like, the position of things. But this is very much not semantic. It's impossible to know what we're talking about. There's no significance to that markup that you're looking there, right? So I'm going to have an old man rant here, if you allow me, right? So we live in the post-React era, and the thing about the whole React phenomenon is that for a long time, people wanted to shove everything into JavaScript and use just JavaScript for absolutely everything. And that's fine. Automation, developer experience, that is okay. But the problem is many younger developers, and especially now with AI, people don't really understand what that thing is building. What is the output? Where's the HTML? Where's the CSS? Many people don't know how to write CSS. Many people don't know how to write proper HTML. And this is a little bit problematic because it leads to bloat. It is important that things mean something and that you understand what you're doing. And it's interesting because many people who are in that side of the divide, let's call it like that, they understand that semantic code is important, but they think that semantic HTML is dead. How do I know that? Whenever you create a React project, you're creating a bunch of components that are very semantic. You have an app component, you have a navigation component, a panel component, a carousel component. All of that means something. When you open VS Code, you look at that, you say, this is a carousel, right? So why are you telling me that HTML, the semantic HTML is dead? It's not, okay? It's just a matter of like, you move the semantics up many layers, but you don't need to do that. And you know why? Because, well, getting back to the subject, HTML and CSS are actually amazing in 2025. I'm not like, just saying this. HTML is HTML. And there's a bunch of features that people are not using, and it's not even their fault. It's just because you were badly communicated, or people just are not aware of that. I basically stumbled on the thing that I'm presenting here today because of that. In CSS, everything basically that you used to do with SAS, you can do with CSS now. CSS has variables, it has calculations, it has nesting. You can actually, instead of just like throwing a bunch of classes, you can say, this thing looks like this. And when I have a header inside of this thing, it's going to look different from the header that's outside. You can define it a generic header, and then when you go and you nest it inside of something else, like a definition of a tag, it's going to be different just in that case. Okay? And that actually makes you understand like, the C of CSS, which is cascading, much better. It should have been like this since the beginning. But anyway, it is like this now. It's 2025. Look at that. So putting all of those things together, and specifically, these things are custom tags and a bunch of new CSS stuff. It felt like coding in the future, right? Coding in the year 3000. So that's why I call this thing HTML 3000, okay? It is a joke, but seriously, it is very different. And it looks actually very different, but it's just the same old, but a little bit better. So what is it? Let's talk about the principles. To begin with, your priority is to say what a thing is first and foremost, and then you think about how it looks. And to do that, you do like so. You use custom tags. You don't use div or spans. You rely on context and nesting instead of using classes, okay? It's not that you can't use classes, but I'm telling you that you can live without them, and actually this makes your code a little bit, way more legible actually, not a little bit, okay? Since we're talking about being semantic and people like declarative code, that's all that React people love to talk about. We double down on that and we use attributes instead of CSS classes to SCSS hooks so that you can change things. And we're going to see this in the examples that we have. Also, you think about patterns first and you componentize later. Because if you can read your code like this, you really don't need to build a component many times. If you know that the structure of a now playing component, yes, this is what we're talking about, the tailwind example, but like this. You can just say, oh, I can have a cover art. I can have a track information in a little block, and then it's going to have a track name, an artist, and album info. I am assuming that's what it is, because again, from the tailwind example, it's completely impossible to know which one is which. So I just I made a guess, essentially. And yeah, this is functional code. I actually have a live example soon, and we're going to play with it. Also, and this is the right community to talk about this, but JavaScript always comes last. Okay, I'm gonna duck and cover now. But it's true, the behaviors, the things that you need to add the interactivity, it comes last, okay? You think about the structure first, you make it work, you make it look good, and then you think about how it's going to work, and you attach. You can use a bunch of things for that. You can use HTMX, you can use Stimulus, you can use all of those things that nobody here probably cares so much about. But you can also use this with React, with Vue, with whatever. This can be the output of your component. And it will make your life simple. You don't need to put the CSS inside JS anymore. I mean, if you really want to, you can, but come on. So, a couple of examples. Aha. So now I need to zoom in probably, because this is tiny. Okay, so this is a code pen, as you can see. Hopefully the code is legible enough. I'm gonna zoom in even further and do this. But on the left is the markup, on the right is the CSS. This one is actually SCSS here. I'm using mixins. I have another example that uses just pure plain CSS. But essentially, this is the now playing component. Here's the preview. Now, here's the cool thing, okay? This is the horizontal version. If I want to make it vertical, and this is just like an HTML attribute, I can change it to vertical here. And then, through the magic of CodePen, now we have a vertical component. This is something that they do on the, at the Tailwind home. Okay, how this thing is defined. There's something for the background here, and then you have a couple of mixins, one for the vertical version, one for the horizontal version. But the way that the component is defined on CSS is, I'm just using a CSS tag here. There's no dots, there's no hashtag. This is just, if you just put the name of a tag, then the styling is automatically for the tag. Then I include with whatever I want here to be the default version. If I change this to vertical, it's going to be the vertical, and then, it depends. And notice that I'm nesting the cover art definition here. And images inside the cover art are going to look a certain way. And then I have the track information. And again, it's track information. It's one tag that encloses everything. And then I define track name inside track info, and then artist, and so on and so forth. Right? And then I have, this is the way that you actually access the HTML attributes. You just put them inside square brackets. If you want to do it differently, if you want to use like an equal sign, like, I don't know, arrangement, horizontal, vertical, you would just put like, something like arrangement. I can't think of a better word now, okay? That's the only reason. And then I can do vertical. And then it's going to change. Notice that it changes there. It changed the preview too, but then I can go and do arrangement equals vertical. And then it's going to change again. So you have many options to actually do this in any way that you want. Another example that I have here is like a simple badge component. There's a bunch of them here. Notice that badges can have a number or not, like a count, right? I'm just creating like a badge group, which is the white thing. And then I have a badge component which simply receives a text inside, right? And if it has a number, it displays a number over there. And how is this defined? Same way. I have a badge group, and then I have a badge. And then there's a number that is defined within the badge. And then I define how each one of the configurations are different, because I have primary, I have danger, I have success. Like, you know, it's a very common use case. The design is not the best because I'm not a designer. But you can see that the primary, it changes the background color and the color of the number, same thing, okay? Always using nesting. This is pure CSS, this is not SCSS. So, yeah, absolutely, you can write it like this. And it's just, honestly, it just looks more organized. You can criticize my CSS skills or whatever, but that's not the point. The point is that you can do this, okay? So, going back to the presentation. So, actually, the first time I showed this to people, they asked me, so is this a design system? It's not. It can be used to create a design system. But the whole idea is that whenever you think about what you're doing, which is kind of what I'm proposing here, okay? If you give a name to your components early on, if it's not just like a bunch of tags, a bunch of div tags with a bunch of classes, if you say, I am creating a panel, I am creating a carousel, I am creating a now playing component, a badge or something like that, if you name it, you will think when you want to add things inside. Okay, because you will think, okay, so what do I need to show here, right? And then this will make you organize your thoughts. It's going to push you in the direction of creating a consistent user experience. Because you're giving name to things. And because you're giving name to things, everything just becomes clear automatically. You don't need to create a bunch of nested divs just to maybe add spacing, okay? I created a badge group because I needed to group them together. But I could create a badge subgroup. I could create any things like that instead of just putting spans and divs. And it just like automatically becomes a thing that makes sense. And if you created any apps, you know that eventually you need a design system, okay? So if you push yourself in that direction, you're probably doing a better job than just like randomly just splashing tags on your code. So it's good that this encourages you to do the right thing from the beginning. All right. But Fabio, I'm too set in my ways. I want to use classes. I love classes. When I sleep, I dream of Tailwind, and I really love it. So can I half-ass it? If you really want to, it's still beneficial, and you know what? It's fine. Okay? So this is the same example that we looked at before, but using custom HTML tags and classes. Is this valid code? Let me tell you about it. It is. Here is that code right here. And it works exactly the same way as the Tailwind example, with one difference, because actually when I was doing, reproducing this example by hand, I noticed that there was an error on the example code on the Tailwind website. And by the way, if you ever try to copy code from the Tailwind website, it sucks. I don't know what they did, but you select a code, when you paste it on any code editor, it's going to be a mess. It's not going to be properly formatted or whatever. They really need to look at that. But after formatting the code and making it work, I noticed that it was wrong. So I actually fixed it. I actually don't even remember what was wrong anymore, but trust me, try this experiment yourself. Like, there's a website at the end that has like all these code pens and you can play with them. Anyway. You can call this HTML 2030 instead of 3000. It's not quite as futuristic, but you know, it's going to get you there. Right, references. I'm not the first person to think about any of those things. Actually, this whole thing started when I found this amazing article called CSS Classes Considered Harmful. It's hilarious. It's super well written. It goes into a lot of depth about this. And it kind of reaches the same conclusion that I did. And I said, no, this can't be true. I need to try this. And then when I tried, I was like, OK, so this is the thing now. Another one's more recent about why semantic HTML still matters. And finally, there's one that I think it came out last week, is just use a button. It's the argument about, like, you know, why would you use a div with a bunch of JavaScript attached to it when you can use a button? Yeah, just use a button. Just do it, OK? Finally, Pico CSS. If you want a starting point on CSS that follows this, okay? This is a very minimalistic CSS framework. And one of the versions that it's offered is one that's very purist. It doesn't have any classes. It's just like HTML tags, has like lots of variables for colors and things like that. But if you have some plain looking HTML and you just attach Pico CSS, it's just going to look good by default, essentially. And then you add your own stuff and your themes, and you go from there, essentially. It's a good starting point. So, questions? There's a couple there. How do we do this?
Maybe attach your mic and I'll just run.
Okay, okay. There's another mic there?
Oh, there's another mic. Okay. 1 second, we'll get you. All right.
Okay.
Raise their hand.
Excellent presentation. My question is about how the custom tags go along with the search engine optimization and the accessible devices like the devices which just reads out loud, and the older elements like header, footer, article, summary, those are very useful for the accessible devices and also useful for the search engine optimization.
Yeah. So I'm not saying to do not use the existing tags. I'm actually, and I should have clarified this because it's a thing that came up before. You use the standard HTML tags as much as possible. When they don't represent what you're putting on the screen, then you create your own custom tags. That's how you should do it. And by the way, everything you're going to have like a header or like paragraphs and stuff like that. Whenever you're displaying text, you should absolutely use those things, okay? But you should also use the area arguments, like attributes, because actually all the different accessibility options, they look at that. They by default are going to look into header, paragraphs, and stuff like that, but all the area attributes are used for that too. And as long as, when it comes to search engine optimization, same thing, okay? Certain things like having an H1 that is related to your tag and to your logo and stuff like that, they absolutely still make sense. But search engines actually will read the full text of your markup, no matter how it's wrapped. So in the end, it actually makes no difference. And as long as you follow the existing conventions of accessibility, everything should be fine.
Hello, thanks. 3 questions, but they're easy ones. So first one is, can you do this since before HTML5? Like, is this a thing that has been there forever?
I don't know.
Okay,
I know that after HTML5, this was supported in, for sure, in Internet Explorer, like in 11 and 12, they could do it because they, used HTML5.
It works now, so that's what matters, right?
Yeah, yeah.
Second one, does this affect SEO? Kind of like, is there an issue if like Google cannot like parse your page because you're not using?
Like I said before, like there's no real impact on SEO. Actually, I just put, I forgot. I just put the website online, and like Google just found it just fine, right? Now it is an article, though. It's formatted like an article because the document tags actually worked for my use case. And again, I'm not saying do not use the standard HTML tags. I'm saying that whenever you hit a wall with those, then you can use because I'm talking about using those for panels, switches, all the stuff that doesn't exist on HTML, then you can create your own custom tags for that sort of thing. Yeah.
And also, how does tooling play with this kind of like, you still get like autocomplete, like can you do linting and things like that?
That's the coolest thing, okay? So I know this for sure on Zed and VS Code, which are the 2 editors that I'm using these days, okay? They absolutely understand that whatever you put inside the tag, the angle braces, it's a tag. So it knows how to close the tag, it knows how to format everything, it just works, okay? Even if you're not using Copilot and stuff like that, editors these days are extremely smart. Actually, VI does that too, because the Vim plugin for HTML actually understands how to close those tags. So, and also you need to remember one thing. Even though those are not web components, okay, web components use custom tags. It's just like custom tags plus JavaScript for behavior, okay, that you define as a class and stuff like that. So this was a thing for the longest time, but I don't know exactly, but for many reasons, it was not presented as, oh, you can use custom HTML tags, but they are not as, like, coupled to web components. Those are kind of like two different things that you don't need to use at the same time. Like, you don't need to use full web components to use HTML tags. You can just like separate them, which is kind of the idea here, right? Whenever you want to add the behaviors and stuff like that, then you create a component, then package it, add a bunch of JavaScript, and you do whatever you want to do. Yeah.
Thank you.
Any more questions, or time for one more? All right.
So I saw in your examples that you are using kebab case for the tags.
Mm-hmm.
Is that the recommended way, or is just your preference?
That is the recommended way to do it for custom HTML tags and web components. That's why whenever you see a web component, it is kebab case. If there are any Rails developers here, there's one. So there's this thing in the modern Rails that's called a turbo frame, okay? And a turbo frame is nothing more than, it is a web component, and it uses a turbo-frame. And what it does is like, it's essentially the same thing of the islands philosophy that we've seen in Remix and a few other React variants, that you do the server-side hydration. First you deliver the whole content, and then you hydrate. So Rails has this built in since version 6. Sorry to disappoint all of you thinking that you were super modern, but this is a thing that exists in Rails. It's standard on Rails 8.1. Actually, I think, if I'm not mistaken, Phoenix Live Views also does something similar. And it's great stuff, really. And honestly, the whole Remix thing, I think now is like 10 stack too. All of those frameworks are much better than React was when we started using them. So the things have evolved everywhere, right? And it's a great thing.
All right. You can always talk to Fabio after the talk. So
Yeah.
we're gonna switch to the next speaker now. And thank you.
Okay, yeah. Oh,
Oh, you can just put it on the table. Yeah. You see,
the magnet.
it's tricky.
Yeah, got it. There we go.
Before today, I thought everything was a div. So. Thank you. All right. There you go.
Sure. Oh, I see.
Let me know. Before we start, just want to quickly check. Yeah? No? Okay. Cool. Well, hello everyone. Before I start, just want to see how's the energy. Just raise your hand if you're feeling good. If you're starting to feel a little bit down, let me know. I will start doing a little bit more quiz around it and try to boost that engagement around. My name is Jatinder. I love to have engaging, quick back and forth discussion. I don't want to do just one way, just dumping all the information that I know towards you. If you feel like in between it's starting to go really advanced, just let me know. I will drill it down. The idea about zero to master or zero to hero is literally start from something really basic and see how the crowd is actually feeling like. If you start to feel like, oh, you know everything about the level 1, level 0, level 2, level 3, then I will keep stopping in the pit stop and try to make a couple of engagement questions, and I will see like how we are doing. Before I start, how many have you actually built a system design and deliver and then fail, making some production error at the end? Perfect. How many have you struggled in interview correcting system design or even failing it? There's 1, 2, okay, amazing. So I'm gonna leave this one in such a way that you're able to communicate some sort of system design discussion during the interview. I'm gonna start with myself. My name is Jatinder. I have been doing this in last 12 years. I started with different industry. I love switching industry, try to get the gist around how industry work. I work with a healthcare, luxury brand, e-commerce, retail, then SaaS, and now recently I joined Raya, which is a dating exclusive invite only celebrity app. It's a social networking app, so I'm really enjoying over there as a senior server engineer. But there are a few things that I put it over here, but at the end, I'm gonna share my LinkedIn profile. Feel free to go and stalk me out, and then if you like it, then definitely follow me. We will definitely have a continued chat around that. So let's start with a bang. Oh shit, so big bang. Everything starts with a big bang, but we don't wanna go that far in the past. We're gonna switch back and get to the level 0. With any system that you ever work on, like it could be an HTML application or it could be just a one API that you have built. If you have ever built one API, these are the 3 things you have worked through. You don't have to focus on what's inside it, just focus on the outside component. Any system that you're going to work on or any system design discussion with the peer or the interviewer you have to think about these 3 things: front end, middleware, and the back end. Don't worry about the database, don't worry about the cloud, don't worry about the whole system outside of the net. Focus on these 3 things because this is the core around every system that you use. There is going to be some front end where you will have user facing. As a system design, the beauty of system design word itself is it defines what it's trying to say. It's a system that you don't like to design. That's why I love this word. Imagine you're talking about a waterfall, right? Waterfall, amazing word. Water is gonna fall, it's defined itself what it's trying to do. Exactly, that's your interviewer, your peer, anyone who you could like to talk to is going to listen to you only when you're able to communicate what is system you're trying to build. And then in the front end, you can design any front end language. In the middleware, you can design any express or routing language. As a system designer, it does not care, right? And the backend, you can design work on any backend, use any GCP or AWS or Azure. No problem at all, as long as you know what you're trying to deliver. In the system design, there is 3 things you always have to remember, and this will help you to design a system or working with the interviewer or working with any smaller to bigger problem. You have to know the functional and non-functional requirement. Anybody know about these 2 words, functional and non-functional requirements? If you know, amazing, you're gonna go really well in the interview. If you don't know about it, please do yourself a favor, learn a little bit about it, because any system design you're ever going to build, it's always start with the why. Why I am building this, what I am going to deliver from there. It's not just jumping into the solution and start building, it's collecting the data, collecting the information from the other party. Only at that point you have to think about which I'm gonna choose. Imagine you're building a Instagram image uploader. If you don't know how many people are going to use that service, you cannot even predict which services you're going to use. So functional, non-functional requirements are definitely must. And then back of the envelope discussion. I'm gonna stop here. This is level 0. Just knowing how to start a system design. You're gonna have 3 components. Each component can have any technology that you love doing it. But from here, we're gonna go a little bit into advanced. Level 1. I prefer AWS just because sheer amount of the documentation that they are holding. That's why, but you can choose any cloud platform that you love. This is is it too small to read, by the way? Okay, let me see. Cool. So, I love to discuss certain things with a very layman term. Like I don't want like to have really complex theory around certain topics. It could be explained in everyday life. If you're an engineer, if you look around yourself, any concept that you have learned during the graduation or during your first year or 5-year learning or 10-year of experience, the more year you're gonna have your in bucket, the more you understand that every single thing around you makes this system design or the discussion or the concept that you love to learn through. And that's where I put, like, your toolkit of any AWS or Azure or GCP is going to break into these three things. There is going to be some front door, like there is going to be some API gateway, which is going to be like literally going to a restaurant and they will say, hello, welcome, let me route you. Right? That's literally you do when you go into a restaurant. Then there are workers, there are hostess, there are people who are going to let you in, try to settle you down, try to give you the menu. So those are the workers. Then comes the messenger. Messenger is like your deliveries, like how the food is going to come to you, how much time it's going to take to reach to your table, how your order is going to deliver to the back of the kitchen. Those are your messenger, and the brain is the chef that is building everything behind the scene, the ingredients, the recipes that he's building around. So every stage actually going to relevant towards what in the AWS or GCP is going to use as a service. Front door is API gateway, workers are going to be, for example, Lambda and EC2, messages are going to be SQS, SNS, and brain is LLM host, or in normal language, any backend. With these five or six services, you can actually design any sort of smaller to a mid-range system design questionnaire or any interview solutions. So I will say if you ever struggle through an interview answering this thing, at least get to know about these 5 to 6 services, and that should be good enough. Perfect. Before I get to level 2, I'm just gonna get my water. I'm not sure why I'm getting my. Alrighty. So level 2, the secret sauce. The idea is like any system design or any programming language or any discussion that you're ever going to have is going to have some core concept. The concept that's going to define how much you know about certain things. If you're saying that you know Node.js, and if I ask you, can you explain event loop in a way that the other person can understand without knowing what Node.js is? If you cannot communicate in certainty around the words language, that means you don't know the concept that deeply. So make sure that whatever you know, whatever the concept you're learning, whichever language you're learning, you should able to communicate with anyone. And if you're able to reach to that level of communication, you will never have a struggle with communicating with peer, with your manager, with your even interviewer. That's the whole idea about a communication working through the tech stack. And that's where the 4 concept comes in. There are many concepts, but these 4 is really crucial to build any system design or any smaller to bigger language, bigger system. Async programming. Who within the crowd actually able to explain within like 2 statements like what async programming is? To make sure like we able to communicate? Yeah, go ahead.
Something that's not timed.
Perfect. That's exactly what we're trying to do. Something that we don't need right now. You just trigger it and just let it go. And then behind the scene, whenever it's finished, we'll get back to you. The event loop is a simple example of async programming. Running a message, sending a message to your peer. Let's say you send a message to your peer on the Instagram. It's not just reaching out directly as a WebSocket. There could be a chance that it's running through a queue, priority queue, and that it's scheduling over the period of time. And it might be instant, it might be take some time, but then there is something going to be async programming behind the scene that all these resources are not going to be stopped for you to finish your execution. So that's one concept. Second is decoupling. Without that, you will get deadlocks. How many of you actually know deadlocks? Come on, engineers, we are engineers, right? So that's second thing, decoupling. You need to make sure your one resource does not block your another resource. Race condition, rate limiting, all those concepts derive from this second concept. You have to think about that if you're designing a Lambda, and that Lambda is going to block your database row, like one of the row, and that other Lambda is trying to get that row. You kind of build a block over there. Recently at our company, we have this issue that we were deleting to support GDPR, we were deleting all the information of a user because he ended up deactivating his account. So we were deleting their data, and one of the process behind the scene tried to update one of the row. And what happened, one process is try to update and other processor try to delete. And this create a locking mechanism on that exact row. It is exact row. And what it triggered, for 1 hour, the database just keeps spiking. The resources are keep drilling into, and we try to figure out where the problem is going on. The reason was these two processes or these two jobs try to run together onto one single thing. That's what creates this problem. That's why the decoupling becomes one of the crucial factors when you're designing from any system or any solution that you're. It doesn't need to be a system design solution. It could be a simple program that you're running. It has to have decoupling around it. Third things around queue and messages. This is literally one of the crucial things. Without that, you cannot build a huge system. You cannot proceed any action right away. You have to schedule it like a cron job. You have to wait until the time comes to finish it up, right? So queue and messages are become one of the easiest things that you can test and that you can actually communicate. For one example could be literally a queue in front of a Tim Horton, right? You literally create a queue, you process your order one by one. But then explain me if this is a queue where you're gonna get your coffee one by one, one after one. What you will tell a mobile order, like if there is one queue where there are people are standing waiting for their coffee one by one, and then on the other side there is a mobile order. How do you distinguish between these two concepts? How can you define that what this concept actually means? So if you remember, there is one called standard queue. Standard queue is like literally simple queue. It's simple, easy, implement, it's cheaper. The other side is called priority queue. Something that has to happen right away. For simple example, if you have a bank and you basically, let's say, connected with the Scotiabank. Scotiabank want to send you a marketing email, right? Do they have to send this marketing email right away at the same instance? No. They can schedule it. They can slowly provide toward the population, so they don't have to use their whole resources at once. But something has been debited from your account. Do they have to provide the information right away? Yes. That's where the priority queue comes. It's an expensive resource. Not every resource is going to use this priority queue, but certain will be. There are many examples you can think of. You are on Instagram, you're available right there, right? You're online at that point, and one of your friend become alive on the Instagram. You get a notification instantly. But if you are not accessing or not using Instagram at that point, you're gonna get that notification after a delay. It's not gonna be as instant, because as Instagram, they want their service to feel like real life. And that they want to make sure when somebody is doing an action and you are at the Instagram, it feels to be right away, right? So this is basically comes around queue and messages to making sure what is standard and what is priority. Who can actually explain idempotency? Anyone want to try? Yes, sir?
Idempotency is basically if I execute a process once or more than once, the state at the end of it will always be the same.
Exactly. Exactly. Beautiful. If you can just do a quick clap. This is such a simple concept, but that's actually comes around most of the interview if you're going towards 3 to 4 years of experience job. If I end up on the other side of the interview, I'm gonna definitely ask you this thing. Because without this, of course, without any of this, the system design won't finish. But this is most important. Imagine that you are buying something on Amazon, right? And for whatsoever reason, their buy button, the payment button, is just for whatsoever reason is slow. Like it just, maybe it's on your end, you have a slow internet connection, or in their end, their system is slow. You click once, nothing happened. You click second time, No. You keep clicking a couple of times, and then you waited. And right away, you receive a Scotiabank notification that something has been deducted from your account 5 or 8 times because you clicked 5 to 8 times. You will never get back to Amazon. You will never able to just go and buy any because you will lose the trust. That's where the idempotency comes. No matter a action you try to repeat, a certain action, not all the action, a certain action, no matter you do it once or 1,000 times, the end result has to be same. So these concepts are something you will able to learn pretty quickly with using ChatGPT with simple examples. Just tell the ChatGPT or any GPT model that I am trying to learn this concept. Can you show me a real life problem or real life example? Look into the Tim Horton example. Look into anything with the banking example. So they will give you a quick examples around it. Build the story in your head. Once your story gets settled down with one of these concepts, it's become much easier to communicate, right? You don't have to be very technical with anyone, right? You don't want to share this technical information with your manager. Manager even don't know about everything, right? They're gonna try to figure it out. Are you on the same track or are you not, right? They are going through a script. So if you're going too far into it, it's become a little bit trickier. How many of you actually feel confident up to now? Because things gonna get really crazy ahead. Amazing. Okay, let's go level 3, Gen AI. I actually try to focus on Gen AI a little bit because somehow it's a cliche word that as soon as I put it on screen, everyone's eyes just pop up. They were like, oh, this is important, right? And it is important. So I'm gonna focus on the system design pattern and give a kind of spice around Gen AI. Why Gen AI and system design both are really important. Imagine you join a new company and they are using all amazing LLM tools and you get access to one of the LLM tools and you end up building something super, super interesting and you launch it, everyone loves it. Everyone is talking about it. Bravo, bravo. Middle of the night at 3 a.m., some bot attack happened on your website. You didn't have set up any of the rate limiting, rate caching, anything. In the morning, your manager gonna call and then they're gonna say like, I have $120,000 of bill on my LLM. Who's gonna pay? So that's why LLM is an amazing tool that you're gonna use, but how you're gonna use it is up to you. And system design and this concept allow you to put a blocker around it. Right? That's where two things comes. And all of my examples gonna come with a very playful messages like synchronous, like it's a patient pattern, like impatient pattern. You're gonna request and you're gonna wait. You need the results right away, right? It's like talking to your mom. If you say hi, it's gonna come out right away. You can't wait until like, oh, I'm gonna call you back. It has to go right away. That's synchronous. Asynchronous is like you're sending a message to your girlfriend and waiting for like next day. That's asynchronous. Chill pattern, you don't have to wait. You basically just set back, trigger it, go back, and then wait until that things will finish. And with these two patterns, you can build any of the story around you, like any concept you build up. Like if you think about a social application or a Gmail application or any application that you think of, these two concepts gonna run in parallel in most of them. And that's basically how we're gonna go into 4th level. We're gonna work through a couple of patterns now, like how Gen AI and system design work together. I know there are a lot of services I put it there, and they might not be even visible, but you don't have to think about the services inside it. Just look at the main levels: client, API, middleware, LLM host. And if you can look into the numbering, and if it's visible at the very end, that's all I need. And if it's not visible, please let me know. I will try to see if I can zoom out. Is it visible enough, the numbering, the counting that's going on? Well, for you, it's gonna work really well. So the idea is, if you go with a synchronous pattern, we talk about it, like it's impatient pattern, it has to come right away. It's like you make a request to ChatGPT that, okay, give me 2 + 2. And if it wait for 5 minutes, it's not gonna work really well. It's not a right user experience, it has to be instant. So there are certain things that even ChatGPT do synchronous, and there are certain things which is take around asynchronous. One of the example, really quick example will be something that you ask directly or something you ask with the research. as soon as you toggle the research button, it doesn't do right away. It's go in the behind and start doing it. That's basically what's happening over here. Certain messages that goes from client to API to middleware to get the LLM host right there around this area, right? Middleware to LLM host, it try to build the response around it and get back. And there is certain things happens that you can go around other models as well, but eventually it's gonna finish the loop. You're gonna go 1, 2, 3, 4, 5. It's literally your basic HTTP call or any API call you ever designed, right? So if you have ever designed one API call with Express or Node.js or Next.js, whichever language you like to do, that means you can talk about this pattern. And think about like if you want to share this thing with the flavor of GenAI with your interviewer, you can able to communicate it. You know this concept, it's just like, it's not something you have think through it, right? Please let me know if I have time to continue. Perfect. Okay, so second concept. It's literally, we did a synchronous loop, 1 to 6. Now we are trying to go asynchronous. Asynchronous, we did talk about that. It's a chill back pattern. You have to make a request, and the server will do its things and get back the response when it's ready. So literally what it's trying to do is basically building a contact between client and API, going to middleware LLM, but you see like connect and send message, and it's just try to wait around it. And while the concept has been finishing up, when the result will be ready, it's going to push back over there. By looking at this scenario, can you judge like which technology I am using around client and API? What sort of tech I am using? Like you know that there is a REST API, then there is a SOAR API, but then there are other concepts as well where you can communicate with your server. Yes, sir. There you go, WebSockets. That's what is happening. Asynchronous pattern literally means like you make a contract between the server, but server doesn't have to respond to you right away, but server knows who are you. And then whenever the results will happen, they will return back you. That's basically the literally asynchronous pattern is. And pattern 1 and pattern 2, you have used million of time or multiple time in your projects. It's just how you're gonna communicate to others in a way that, and how you implement eventually. And of course, trade-off. Next, the only change of this flavor around here is, previously we used WebSocket. WebSockets are really good with smaller responses. If you are carrying like few MB of data, all good, WebSocket will handle it. Imagine you are downloading from Toronto a new movie around 3 GB. WebSocket is not going to work really well. It has to be, what? Streaming. It has to be going through tech stack streaming. It has to go through with a way that you don't have to get the full result at once, you get chunks of results, pieces of results, right? And that's how you watch Netflix or any platform that you use. And that's basically they have using it. So best user experience need WebSocket or SSE. I did say WebSocket, but of course, based on the size of the data, it either switch toward WebSocket or it will start doing web streaming. Cool. Before I get to level 4, and level 4 plus means it's just your number of years of experience you're gonna build around. You're gonna build smaller system, then you're gonna build architecture of a bigger system, and that's level 4 and plus can go up to 10, 20, up to you, like how far you wanna go ahead. But the far you go ahead, the better you will understand bigger tech stack, the bigger companies, how they think through, how they process through for 50 clients at once to 3,000 requests per second. And that's the real challenge. And that's what most of the companies these days are trying to aim for. They want that their system able to handle 1,500 or 200 requests per second. Imagine 200 seconds, like within a second, 200 requests has to process within the system. And if you don't choose a right stack or right system, you're gonna blow the server. Monolith works really well, no doubt about that. But if you have a bad monolith, it's gonna blow up, right? You cannot vertically keep upgrading that. So before I go to level 4, always imagine that no system or no choice is actually your own choice. You don't have to make a personal choice about sticking with pattern 1, 2, or 3, or 4. Or choosing that, oh, I'm gonna go with AWS or GCP or Azure. Or I'm gonna go with JavaScript, or I'm gonna go with Java. Think about a trade-off. You have to always not put up yourself first. You have to think about what company needs or what a project actually needs. If your project has to be a short-term POC, you don't want to build a Java language. You don't want to go with the Hibernates and then build a complete framework around it, because it's going to take months to establish a better framework. But since it's this POC has to handle within a few weeks, you can just do with the JavaScript. Imagine now you have to build a system design, but the system design had to go with a smaller number of customers. Like there are 20 or 50 customers. You can build synchronous pattern at that point, because your services, your system resources are enough to handle that cloud. But as soon as the number of customers gonna grow up, then you have to switch to the second one. So always think about the trade-off, like what I'm gonna get and what I'm gonna lose. The CAF, if you have ever heard about CAF theorem, you're never gonna get what you really want 100%. Something will gonna get lack, right? That's the trade-off you're gonna make with the system. And most of the discussion that you're ever going to have on the interviewer about the system design is just to understand that trade-off. Your manager or your interviewer trying to share with you something that they want to achieve, but they cannot achieve, and you have to pick what they cannot achieve. And that's the trade-off, and how you're gonna fill it is based on different patterns, different technology, different system. So that's basically the learning curve you will get. I'm gonna go to level 4. Level 4 has no difference between level 3, but it just has more complexity around it. Now it's buffered. And if you think about buffered, means it's not just something that you will get the response in short period of time, or during our streaming services that you have a constant loop back. Buffer response goes a little bit different. It is 10 times cheaper than you're processing one by one, definitely, because it's not something that you are processing completely. You make a request, behind the scene, it's just whenever the resources are available, it's doing its own thing. Resources are consumed, it's gonna stop. Have you ever worked on Jenkins? CI/CD Jenkins pipeline, right? It's not infinite resource. If your company is 20 people, you are running 50 services call within like an hour, it's gonna work fine. If you have thousands of people, your job's gonna get scheduled, right? You trigger a job, it's gonna say, resources are not available. I'm gonna wait and then trigger it. That's basically the batching. You did a batch behind the scene. Whenever things get started to feel naturally available, it's gonna do it. Once completed, push it out, and then do the other thing. The easiest example you can think about it is stack. If you know the data structure stack, that's exactly what batching is. You put something in, whatever goes in, you go put another thing, put on the top again and again and again. Whatever is becoming available, it's gonna execute, throw it out, then bring another thing. So at the end of the day, where we are getting in, your system design cannot be completed with your data structure understanding. But if you're able to communicate clearly what you're trying to build, then you can bring this concept in to make your understanding even further better. But without that, it starts to become a little bit trickier or difficult. And this actually, the whole thing is available in AWS white paper. If you like to have those links, let me know. I will be able to share with you. This is like part 1 and part 2. They have explained it really well, better than me, definitely. But a lot of documentation around it. It won't be as easy as just quickly going and reading through it. But if you're able to match this understanding with your real life examples, it's become really quickly adapting to that. And like I haven't even touched any of the services that they have been using. The core concept, if you know, then you know that, okay, you know what, if I need to do the buffer, I need SQS. And that's the whole beauty around it. Once you know what you're trying to do and which service is going to do it, then you can go ahead and then start learning around it. But imagine you don't even know the queue services and you have to do certain things, you will completely go into ChatGPT and try to figure it out by yourself, right? But on an interview, it will be trickier. The last one. The last one is literally one way. And I'm not gonna tell where this usually used. Of course, it's written right there. But you guys have to figure it out what example you can think of that this pattern might end up using. It's just one way. There's one data source, there is something going on in between, and eventually it's been stored somewhere else. Just take some time in and try to think about like where this pattern can fit really well. Yes, sir? Amazing. So analytic dashboard, stock, every application stock you, right? We all know that. But that doesn't have to go real time. It can collect the data that they have stock around you, and then eventually do one way to build a social profile around you. Data processing, all the data pipeline that you have or in your company have it, that's how they actually go one way. Collect everything that they have, run after 24 hours or 45 or 48 hours, and then execute slowly and then dump it down the eventual data. Then the term actually comes, and at the end of the day, eventual consistency. Eventually, you want your system to be consistent, right? You have to have all the data available, but eventually, it's not real time need to be done. And if you have your camera with a good camera, just take this screenshot, because this is the cheat sheet. Literally, whatever I have explained, it's dumped down on one page. On the left side, you have different pattern that I have explained. On the right side, you have when you're gonna use it, what's the highest trade-off you're gonna make, and the real examples around it. Real examples are almost like to make it simple for you to become relevant, but do not share this example right away in the interview. Try to build the concept around it so that you can communicate better. And if you couldn't able to make a screenshot, and if you really need it, let the organizer know, and I will happy to share my slides with them, and you can able to download it somewhere and then use it. And thanks for hanging out. That's all about it. Thank you so much. And the last thing I would really want to go through is try building something and breaking something. That's the easiest way you can learn around it. As long as you're not breaking it, you don't know how to fix it. Okay, so do not do it on production. Do it on QA or staging. Do not lose the company's profiles around it, but definitely do it on QA. That's all I have. If you want to scan this QR code and connect with me, feel free to. If not, then all good. You are wonderfully, really, really patient and engaging crowd so far. And thank you so much for the organizer for hosting this thing and inviting me. And it was really lovely to have this engagement around it. If you have any questions, I'm available. If you want to do it afterward, up to you guys.
Well, we're not going to let you go yet, so if we can take one or two or three questions right now.
I would love to.
Oh.
Do not ask anything complicated, okay?
Hey Jay, great presentation. Really appreciate it.
Thank you.
Just a general question. Do you have any recommendation about the resources that people should use that you like to get better at the system design?
100%. That's where I put this thing out. Once I share this slide, just use this slide as your reference material. I break down, there is only 6 stages. For any cloud that you're going to use, there is only 6 stages. There's going to be more than 6, but you only need 6 stages for the first 10 years of your work. It's going to become really difficult if you go further more than that. You will have storage, you will have database, you will have something you're going to execute on, you're going to have messages so that you can communicate one system from another system through a message. Networking means you have infrastructure that you have to host your services. And the last thing is security and access. Nobody cares about it, but that's important, right? But that's literally you need. And if you have only one services in each block you know about it, you can communicate most of the system design discussion on the table, right? And then as long as you can slowly build around it, that's all you really need.
All right.
Does that answer your question?
Yeah, thank you so much.
Anyone else?
Thanks. Amazing presentation. Thank you.
Thank you.
How would you suggest practicing system design problems while prepping for the interview?
When I was the first time,
Sorry.
Yeah, go ahead.
Especially when it's not a mock interview, when you do it by yourself.
Yeah, I'm like, when I was learning system design 7 to 8 years ago, there was no GPT models, and there is no way you can learn through it, right? The hardest thing around 3-4 years ago, before that, the hardest thing was to build the trade-off, build the understanding like which resource is going to go where. I'm going to give you a cheat sheet, and you can able to crack any interview with that. And for user as well. Just build a right prompt and go to ChatGPT, turn on the voice mode around there, and just tell him, I have X number of experience. I'm trying to crack few system design discussion. Just walk me through for the first 20 minutes behave yourself as a manager who is hosting as an interview and a candidate as well who is going to answer around the system design. I just want to watch you and listen to you that how you communicate back and forth. What's going to happen? As a manager, they're going to give you a certain problem. You don't care about which problem. You care about how they are actually going to talk about two different things. Once you're able to get the gist around it, you will able to build the understanding, and then slowly you will see like, okay, you know what, how the image uploader work. You can build an image uploader, right? Now imagine your image uploader has to have some limit, or you have like 50,000 people who actually use that image uploader for. Now you have to think some solution out. You cannot build service which can handle 50,000 requests every single hour. So if you start with that problem and try to bring the services out, like what services can help you out, you will have first level of understanding. Then go a little bit higher. Go with the messages, right? I have a system that I have to build as a messaging service which is gonna go around 1.3 million users. How I'm gonna do it? Then it's not gonna do your queue. It's gonna ask you RabbitMQ or Kafka. New services kicks in, right? You're gonna learn about them, why they are using. At the end of the day, one of the keyword that I share you, trade-off. Interviewers doesn't care about, or anyone doesn't care about that, do you know able to build the system? If you know about building the system, that means they already know about how to build it. You know what I mean? Like, that's a whole back and forth thing. So they just want to know, can you analytically understand which service is going to go really well or not? Can you able to see the trade-off? And that's going to take you a while. But if you do this discussion with the ChatGPT for at least 8 times, you will have enough understanding to actually build the trade-off and able to communicate. So if at the end of the day they ask you like, oh, why I cannot use EC2? You tell them like, this service is super simple. It doesn't have to have your resource available 24 hours. I build a cloud function. It's gonna execute, finish it, let go. Pay as you go. So that's easiest trade-off, right? Does it make sense? Yeah. Anyone else? 3, 2, 1. Thank you so much. It was wonderful.